All right, so now we're entering the section on differentials. So by definition, dy is equal to f prime of x dx. So we've been using dy over dx as f prime of x, but this actually came first. So dy is f prime of x dx. dx is actually equal to delta x. All right, so let's work on the definition first. So if I just ask you to find the differential dy, so the differential dy will be the derivative of this, so that's secant squared of pi x times the derivative of pi x, which is pi, times dx. So that's the differential dy. This one, I'm going to take the time to rewrite before I go take the derivative. So dy is 1/2 times 1 over x dx. Okay, so that's the differential dy. All right, so now let's evaluate the differential dy if I give you some numbers. So let's go find dy first. So negative sign pi x over 6 times the derivative of this angle, which would be pi over 6 times dx. All right, so I get to put in 0.01 for dx. I'm substituting in 3. So I have 3 pi over 6, so that gives me a pi over 2. And then this pi over 6 is carrying along. So I know that sine of pi over 2 is 1, so I get my dy is equal to negative pi over 6 times 0.01. All right, let's do another one here. So dy will equal f prime of x. So you know the derivative of ln of the absolute value of x is just 1 over x dx. Okay, so x is 1, so that's what I put in here. So I get 1, and dx is 0.05. So my dy is 0.05. So now I'm starting to give you an explanation here of what the dx means. So the dx being positive means that the x values changed from 1 and then moved a distance of 0.05, and so ended up at 1.05. So let's talk about what that looks like on the graph, what the differential looks like on the graph. So here it is in words. dy is the change in the y values that occur on the tangent line. All right, so let's look at this same one because we've already calculated what it is. So let's look at the graph of y equal ln of absolute value of x. So on the positive side where x is 1, it doesn't change any. So you know that ln of 1 is equal to 0. That's a fact that you know, so there's 1. So then I'm going to draw it large so that we can see. So if I move over a distance of 0.05 in the positive direction, that gets me to 1.05. Okay, so we draw the tangent line at x equal 1. So tangent line drawn at x equal 1. Looks like that. All right, so where dy is the change in the y values that are on the tangent line. So starting from this initial point of x equal 1, this x equal 1.5 point, I go up to the y value on the tangent line. This distance from here to here is dy. And we calculated what that is. It's 0.05. So my graph is not to scale, but that's where dy is. The delta y would just be the change in the y values on the line. So on the graph, I mean, change in the y values, on f of x. So here's my original point. If I went up to the y values here, so from here to here would be the delta y. All right, let's continue on. Let's do another one here. We're going to find and sketch dy. So e to the negative x, let's make sure we know what that graph looks like. Comes down like this, right? So let's go find dy. So dy is the derivative, so that's negative e to the negative x dx. So I'm evaluating at x equal 2, and my dx is 0.03. So let me get a calculator so we can see what that number looks like. So this gives me negative 0.004. All right, so let's look and see where that is. So we're drawing the tangent line. So we always draw the tangent line at this x value here. So let's put the x equal to here. Draw the tangent line. All right, so I move from 2 to 2.03. So I move a distance of 0.03 in the positive direction. So here would be 2.03. So my dy, this distance right here, would be the change in the y values on my tangent line. So this distance from here to here would be my dy. And it's negative, so let's evaluate. Think about why it's negative. So it started up here, and it went down a distance of 0.004. All right, let's do it again. So here I have the function y equal root x, and I want to find and sketch dy. So let's go find dy. So that's 1/2 x to the negative 1/2 dx. So 1/2, 1 over root x, if I wanted to write it without negative exponents. So I'm going to substitute in 4, so I get 1/2, and this will give me another 1/2, and the dx is negative 0.05. So I have 0.05 divided by 4. That gives me negative 0.0125. All right, so I'm starting at x equal 4, and I move a distance of 0.05 in this direction. So that gives me to 3.95 on the x-axis. I draw the tangent line at 4. Draw the tangent line at 4. And so where is this distance dy? So dy is the change in the y values on the tangent line. So from here to here is my dy. All right, let's just do one more and finish it off. So here I have the function 1 over x. So 1 over x, looks like this. And I want to find and sketch dy. So dy, so negative 1 over x squared dx at x equal 1 and dx equaling negative 0.02. So I get negative 1 over 1, negative 0.02. So that gives me a 0.02, positive number. All right, so I'm starting at x equal 1. And here is my tangent line. Okay, so there's the 1. So I move a distance of 0.02 in this direction. So that gives me to 0.98. So where is the dy? It is a positive number. It's the change in the y values on the tangent line from there to there.